Today we are modeling fractions. So we're on page 21. Our title is Modeling Fractions. Okay. So when we're talking about modeling fractions, we're actually talking about modeling multiplication and division of fractions, because that's our main focus in the 6th grade. So I have a box right here, and I want to model 1/4 times 1/3. Okay, so the first thing I need to do is to break this box up into fourths. So if I go straight down the middle, and on both sides, now I know mine's not perfect, my lines aren't perfectly straight, and that's okay, but 1/4 is going to be represented by this first box, this first rectangle. That is 1/4. And I'm going to multiply it by 1/3. So I'm going to break up vertically this box into thirds. There's 1 and 2. Okay, so like I said, this represents 1/4. And now I'm taking a different color, and I'm going to represent 1/3 vertically. Okay, so we've got 1/3. Now when I'm solving this, I forgot to highlight our 1/3. When I'm solving this, I want to look at how many boxes have both colors in them. Well, this one's a little bit hard to see, but one full box has both yellow and orange in it. So 1 over, so this 1 represents the number of boxes with both colors, and our bottom, our denominator, is the total number of boxes there are. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. And that is represented by the total number of boxes. So when we are multiplying 1/4 times 1/3, our answer is 1/12. Okay, moving on to a division problem. We have 5 divided by 2/3. Okay, so I have drawn out 5 boxes for us, and I need to split all of these boxes into thirds because we want to separate. We know that division is repeated subtraction, so we want to subtract 2/3 every single time. So if I break my boxes up into thirds, it looks like this. then we're going to take 2 of those thirds at a time. So here's 2 thirds. Here's 2 thirds. Thirds, 2 thirds, and we have not 2 thirds left over. We only have 1 of what we need. So we'll talk about that in just a second. Okay. So when I'm separating 5, when I'm dividing 5 by 2 thirds, I've got 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. But then I only have half of what I need in this block right here. So this is represented by a half. So my answer is I had 7 wholes and 1 half. Now if I wanted to prove that mathematically, I could do our keep change flip. So we have 5 over 1 times 3 over 2. Remember, we keep our first number, we change our division to multiplication, and we flip to the reciprocal of 2 thirds, which is 3 halves. Then if we multiply straight across, that would give us 15 halves. And I know that 2 goes into 15 7 times, with 1 left over, and our denominator stays the same. So I have proven our model mathematically. Okay. Next we have 8/9 divided by 2/9. Okay, so the first thing I need to do is I've got my block and I have divided it into ninths. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These are ninths. I'm going to shade in 8 of them. Okay. So I want to know how many 2/9 can I get out of 8/9. Well, here's 2/9. So there's our first one. Here's 2/9. So that's our second one. Here's 2/9. That's our third one. And here's 2/9. That's our fourth one. So I can get 4 2/9 out of 8/9. So our answer is 4. Now, of course, I want to prove this mathematically. So if I keep 8/9 multiply by 9/2. We are learning about cross-canceling. So 9s can both be divided by 9. 9 divided by 9 is 1. 9 divided by 9 is 1. 8 and 2 are both divisible by 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. So now if I multiply straight across, 4 times 1 is 4. 1 times 1 is 1. 4 over 1 is an improper fraction, so we make it just 4. Okay. Last one. Molly's friend Xavier also has 1 3/8 cups of strawberries. He needs 3/4 cup of strawberries to make a batch of tarts. How many batches can he make? Draw a model to support your solution. Okay, so we know that Molly's friend Xavier has 1 3/8 cups of strawberries. That's what he is starting out with. So we've got 1 full cup that we're going to shade. So we've shaded 1 full cup, and then we also have 3/8 cups. So I bet this is broken up into eighths. 1, 2, 3, 4, 5, 6, 7, 8, and we need 3 of them. So we're going to shade in 3. He needs 3/4 cups of strawberries for each batch of tarts that he makes. Okay, so I have this and it's broken up into eighths, but I need 3/4. Well, I can take 3/4 and turn it into 6/8. Because multiplying our numerator by 2 and our denominator by 2 would give me 6/8. These are equivalent fractions. I haven't changed anything as far as its value. I have just given my numerator and denominator a boost a little bit. So how many 3/8 can we get out of 1 3/8? I'm sorry, how many 3/4 can we get out of 1 3/8? So we're looking for 6/8. 1, 2, 3, 4, 5, 6. So here is our first batch that Xavier can make. Then he needs 6. 1, 2, 3, 4, 5, but we only have 5. So if we went ahead and went on to our 6th, we don't have that 6th component. We only have 5 out of the 6 that we need. So how many batches could he make? He could make 1 5/6 batches. Now, of course, I want to prove this mathematically. We were taking 1 3/8 and dividing it by 3/4. Remember, we can't actually divide fractions, so we have to change it to multiplication and flip to the reciprocal. So I'm going to make this a mixed number, an improper fraction. 1 times 8 is 8. 9, 10, 11. Eighths. Change to multiplication. Flip to our reciprocal. Diagonally, I notice that 4 and 8 are both divisible by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. When I multiply straight across, 11 times 1 is 11. 2 times 3 is 6. I know that 6 goes into 11 one time, and there would be 5 left over, and our denominator stays the same. So I have proven our answer with a model and with math. And that's it.